Okay, we want to make some sense out of zero and negative exponents. So when we have something like 2 to the 0, we want to make sure that it follows all the rules that seem to work with positive exponents. So we already know that x to the a times x to the b is x to the a plus b, right? So if we said two numbers add up to 0, we could say, well, that's maybe 2 to the 0 times 2 to the 0. Okay, so what number, and this is 2 to the 0 times 2 to the 0, so this is 2 to the 0 squared. So what number is equal to its square? Right? 1 is, but also 0 is, so we haven't really got anywhere because we have two different answers for what this 2 to the 0 could be. So let's look at another one. We had x to the a over x to the b was x to the a minus b, right? These all cancel out with those. So we could say, well, 2 to the 0. Now we don't have to stick with 0. We could do 2 to the 5th divided by 2 to the 5th, right? Because since it's subtraction, 5 minus 5 would be 0. So this would have to be true. But isn't this also equal to 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2 times 2, which 2 divided by 2 is 1, 2 divided by 2 is 1, 1, 1, 1, and 1. So this is 1. So that is a little bit more powerful than that, because this we had two different answers, but you could not get a 0 out of this, right? You could not get a 0 out of 2 divided by 2. So this seems to make sense. What about negative exponents? So 2 to the negative 2. Well, what if I made the number on top bigger, right? Because if I had, or the number on top smaller, because then if it was smaller minus a bigger number, it would be a negative. So how about 2 to the 3rd over 2 to the 5th, right? So that should be equal to 2 to the 3 minus 5, or 2 to the negative 2. But the definition of exponents is repeated multiplication, so that would be the same as this. Those would come out like that, and then 2 divided by 2 is 1, 1, 1, and then we had 2 left over, right? So this is 1 times 1 times 1 is 1 over 2 times 2, but instead of 2 times 2, I'm going to write it as 2 squared, right? So that's interesting. So let's see if the pattern continues. So 2 to the minus 3, what's that? So let's do 2 to the 1st over 2 to the 4th, right? 1 minus 4 would be 3, negative 3. So this is 2 over 2 times 2, which 1 and 1. So 1 over 2 to the 3rd. So do you start to see the pattern here that 2 to the negative 2 is the same as 1 over 2 squared, and then 2 to the negative 3 is 1 over 2 cubed. Alright, so I think I see the pattern here is that when it's negative, we can drop it down and make it a positive exponent. Right, so let's continue that idea with variables now. So how about we think about the pattern here. So the x to the 4th, x cubed, x squared, x to the 1st, x to the 0, x to the negative 1. So my pattern is I'm always subtracting 1. And 3. Okay, so what is that equivalent to? So x to the 4th is, let's reduce the exposure. I think that's better. Okay. is x times x times x times x. X cubed is x times x times x. X squared is x times x. X to the first is just x. And now let's look at that x to the 0 again. So what is the pattern that I'm doing here, right? From here to here, from here to here, from here to here. I'm going down by 1 in power, but what am I doing over here? I'm dropping an x. If I think about it as it is this, and I'm going to take away an x, like that's dividing out an x, making it a 1, right? So from here to here, I divided by an x, and from here to here, I divided by an x, and from here to here, I divided by an x. So what would happen if I divided by x again? So I'd have in the 0, x to the 0 slot, I'd have x divided by x, which would just be 1 again. Okay. And now, what if I took the 1 and divided it by an x? Well, 1 divided by x is just 1 over x, and it's to the first power, right? And then what if I took 1 over x and I divided it by x? Okay, so we have to go kind of back to our definition of division is the same as multiplying by the reciprocal. So if I divide by x, it's the same as multiplying by its reciprocal, which is 1 over x. So I get 1 times 1 is 1, x times x is x squared, so that's so dividing by x is the same as multiplying by 1 over x. So that's like dividing by 2, right? 10 divided by 2 is the same thing as 10 times a half. Okay, so dividing is the same as multiplying by the reciprocal, flipping the fraction over. So what if I do that again? I multiply by 1 over x, I get 1 over x, x squared times x cubed. What is x squared times x cubed? Or x squared times x. So it's the same as 1 over x times x, which is 1 over x cubed. Okay, so you can see that the pattern will continue on in this way, and whatever, so x to the negative n equals 1 over x to the what? Does that make sense? Positive n. So this will always be the case if we continue on down to as big a number as you want to go.